Hello everyone, and welcome to today's webinar, The Rise of Smart Factories. Thank you so much that you could find the time joining us today in this webinar, which we are doing together, 2020 and Biesse in our partnership. Biesse has been a partner of 2020 for many, many years. We have a lot of customers together in the furniture industry and have a lot of machine integration projects successfully implemented through that time. Because we highly value the relationship with Biesse, we felt it makes absolutely sense to tackle this very important topic together with them. So I'm very excited to do this today and start to kick this off. A little bit about me. My name is Jörg Brauns, and I'm the 2020 Senior Director of Business Development. I'm hosting this today, introducing the individual people, and if you guys have any questions later on, please feel free to contact me. Today is a very high level at this subject matter we're talking about. Everyone has heard about this topic, Industry 4.0 and so on. And we want to bring a little bit light in this topic. But we really hope getting out of this one is that we have the possibility after this webinar to have a further dialogue and discussion with you to go deeper into this technology and how 2020 and also Biesse tackle this one and together helping manufacturers to get into this new manufacturing revolution. So to start off today, I would like to introduce Diane Burgess. Diane is our product manager here at 2020, responsible for Insight, our ERP solution, which is, most of you know that, the solution for the furniture manufacturing industry. So Diane, it's all yours.
Okay, thanks. Hello, and thank everyone we appreciate your time. My role today is to level set everyone on the basic understanding of the origins of Industry 4.0 and explain some of the common terminology associated with it. So with that said, the term Industry 4.0 originated from a project in the high-tech arm of the German government. It promotes the computerization of manufacturing. It is focused specifically on the manufacturing industry and the goal of ensuring its competitiveness in a highly dynamic global market. Industry 4.0 is really the marriage of advanced manufacturing techniques with information technology, data, and analytics. So much so that it is driving another industrial revolution, one that invites manufacturing leaders to combine information technology and operations technology to create value in new and different ways. So Industry 4.0 is being called the next or the fourth industrial revolution for manufacturing, and that's following obviously the first, which was powered steam engines in the 1800s, then the second, which was mass production powered by electricity and assembly lines in the early 1900s. The third, automation powered by computers in the late 1900s. And now the fourth, 4.0, powered by the internet and web-enabled software applications, capable of processing streams of manufacturing data. And as a practical matter, this revolution, as the others before it, will come about in an evolutionary fashion. It won't happen overnight, and companies will implement in step-by-step phases as it will take a significant amount of time to make the full transition. So obviously the first step being understanding and preparation. And for a factory or a system to be considered Industry 4.0, it must include interoperability, which is machines, devices, sensors, and people that connect and communicate with one another. It has to have information transparency, systems creating a virtual copy of the environment through sensor data that enriches a digital plant model, technical assistance, which includes both the ability of the system to support humans in making decisions and solving problems, and the ability to assist humans with tasks that are too difficult or unsafe. And finally, the centralized decision-making, the ability of cyber-physical systems to make simple decisions on their own and perform autonomous tasks. So with that, there is an additional terminology associated with Industry 4.0. So the promise of Industry 4.0 is that it will bring to manufacturing the smart factory. And that's an environment where machinery and equipment can improve processes through automation and self-optimization. So this structure can include a combination of production, information, and communication technologies with the potential for integration across the entire manufacturing supply chain. So the challenge of the smart factory is the introduction of a new culture with regards to the impact and knowledge of IT-dominated processes. And to get to the end result of the following, of the smart factory, we have the following terminology. So of course everyone's heard of IoT, or the Internet of Things, which is the interconnection via the Internet of computing devices embedded in everyday objects, enabling them to send and receive data. And although you hear it all the time and IoT is commonly used, technically we rely on the industrial Internet of Things, which is the use of Internet of Things technology in manufacturing. So the main difference between IoT and industrial IoT is that IoT often focuses on convenience for individual consumers. So think of like your smart home and being able to set your temperature, or you change your, record on your TV via your phone, while industrial IoT is strongly focused on improving the efficiency, safety, and productivity of operations with a focus on return on investment, of course, in the manufacturing space. And industrial IoT is about making machines more efficient and easier to monitor, and is changing the way industries work. So some of the benefits of industrial IoT are improved operational efficiency, such as uptimes and asset utilization, an outcome economy fueled by software-driven services, hardware innovation, and improved visibility into products, processes, customers, and partners, a new connected ecosystem built around software platforms, and an empowered workforce that comes from a collaboration between humans and machines. So another term you will see commonly used is M2M, or machine to machine. And I believe it's important to understand that while machine to machine and industrial IoT both refer to devices communicating with each other, machine to machine is really isolated. It refers to isolated instances of device-to-device communication that probably already exists in factories today. The industrial IoT refers to a larger scale, synergizing software to automate and manage communications between multiple devices. So the result of all these connected devices gives us what is known as big data. And big data represents data sets that are so large and complex and unstructured that they become difficult to process using traditional data management tools that are in place today. And while creating data is not new for us in manufacturing, we will see that in big data, as more and more machines are connected, the volume will be larger than we've ever seen before. The data will come from a variety of sources and points of interaction, and the data will change quickly as new data is constantly being created and consumed. So it will be the long-term knowledge that we gain from this data that will have the most impact on today's automated factories. So it's important to note that software solutions are typically considered the single source of truth for all data that is being created. These manufacturing software solutions, they host the important facts of your products, your projects, your customers, your bill of materials, operations and cost centers. The software solution that you choose and use must be able to capture and consolidate all the additional data for furniture manufacturers that is being created, and it also has to support improved interpretation and analysis for decision making. Basically, it must be able to provide the ability to use the data that's going to be collected with this new Industry 4.0 technology. So, in summary, I think with that being defined, furniture manufacturers can look forward to the promise of Industry 4.0 bringing more informed decision-making capabilities coming to the factory floor, having an empowered workforce, the fact that big data will play a vital role in knowledge gain and decision-making going forward. And in closing, I think in the early stages, we need to be in tune to cybersecurity issues, as issues can be increased by integrating new systems and offering more access to those systems. Determining in advance for your business what data is important to collect, who will receive it, and how it will be used, and knowing that there is a new generation of intelligent sensors being used that is enabling a new generation of machinery on the factory floor, which is all very exciting. And with that, I will pass it back to York.
Thank you so much, Diane. And now I would like you to introduce you to Jason Varelli of Biesse America. Jason is a brand sales manager over there at Biesse, and he will continue this presentation from the Biesse point of view. Jason?
Hello, everyone. I'm going to expand on some of the things that were mentioned previously and focus more on the smart factory, if you will. And you can see here, so utilizing automation to the merging of the virtual and the physical worlds, some of the things that were mentioned earlier, and talk about more practical things that can be done now, because this is an evolution, as it was mentioned. It's not something we can all go flip the light switch and be there from start to finish that easily. The easiest place to look at where we can implement these things are the low value operations, and I just mentioned a few of them here. So the building of custom stacks for your saw or for your CNC, etc. Many people continue to do this today manually, throwing labor at it, which they feel is inexpensive, yet we all know what happens. So what can be the solution? Automatic storage and retrieval systems, which have now been on the market for several years and are utilizing several of the software functionalities that have been talked about here. The next, and one of the most egregious, is moving parts and material within a plant. Just think of moving stacks versus parts, and the difference in moving stacks versus parts, and which one is more efficient, less prone to damage, much easier to track, especially as we're now well into the reality of higher volume but very small batches for many of us. It's not been an easy transition for several people, maintaining a higher volume but an ever-growing or shrinking, batch size. And then tied into this is the sorting of parts. As we talk about the batch size getting smaller and production staying at a high level, when you get a high volume of parts that are all different that need to be sorted and come back together to go into a box or into the assembly of a cabinet, what have you, whatever your finished product is, introduction now of robotic part sorting to create strict sequences, managing the WIP, no longer having to have people loading and unloading carts. It goes direct to an assembly line, for example, to go straight into that box, straight to the assembly line to build the cabinet, whatever it might be. We do all of these things, all of this automation to gain control and efficiency, which is what all this is about, is gaining control, utilizing things that we already have in ways that can make it easier and more efficient for us. So here is a nice slide talking about efficiency. This is something I found several weeks ago. And if you can see at the bottom, this is something I gleaned from Auto Motors, which is a very strong company in this environment. So talk about low value tasks and how they lead to naturally several disruptions in production versus high-value tasks where employees are more focused and engaged. I like these numbers because it really hits home to several of the things that we see. Whether or not the number is the same as you and what you pay, it's irrelevant because you can put the number to it. So here they calculated just under $15,000 per employee per year. And you can see how it's done based on a $27 hour pay rate and a staggering 546 hours of wasted time. And this time is only done and only calculated for the manual movement of materials within a plant. No other inefficiencies are calculated in this. This is purely the inefficiency related to moving material and what people do when they move material from one position to another position within a plant. And now this is something that can easily be, I don't say easily, can be automated and tracked utilizing the pieces we already talked about. So now I mentioned here, I figured out the 26%. So 26% of an individual's time is wasted, not by the movement of the part, but by the time they waste when they're moving the part. So this is well below the efficiency that we all use when calculating the plant-wide efficiency, which is typically only looked at from an individual efficiency when running an individual machine. So now just think of the options that are available from applying the physical automation into your facilities and the savings that you can have as you start building your smart factory. The second part of it, in control. Everybody wants control. Very few people have control. And there's a lot of different things that you can take control over. I have just a few of them are listed here. So on the first slide, I mentioned inventory management and the production of custom stacks to go out to machines or individual sheets going on to machines connected to that machine. Well, inventory management becomes key. Still today, a lot of people manage inventory on a sheet of paper or an Excel spreadsheet or Lord only knows. Not everybody has an ERP. Not everyone that has an ERP utilizes the ERP because they don't have the forwards and backwards communication from material used out on the floor. It's, I know I asked this much to be cut. I don't know how much I really cut, so I assume I have this much. I need to order more. And then you get into a situation where you have many times too much. Then you do physical inventories more often than is actually required. The next one is the program generation. Think of having programs generated automatically versus how many of us still do it today of generating programs manually and very laborious process, not knowing how long the program is going to take to operate or how long the program is going to take to be executed on the individual machine. Many of these things are, I won't say readily available, but are coming, this part is coming at a rapid pace where you're able to generate the program automatically and then know very easily how long that program is going to take to be run on the individual machines. So it makes it much easier for things to be scheduled and to be scheduled automatically, and then the schedule to be manipulated automatically when there's a disruption on the manufacturing floor. This ties into the reporting aspect. Reporting can be a very wide and open term. Here I'm referring more to the reporting of production and manufacturing, meaning something starts here and ends here, moves on to the next process. Many machines that are already out there today know when it's loaded, know when it's unloaded, but very few people are utilizing that data to know how long it takes from one to the other, to put that into a schedule and to utilize it within a schedule. This ties into the next one of production monitoring and production tracking. A lot of this stuff they all go together to create this smart factory. But production monitoring goes back to the scheduling. Today, when you look at production interruptions, say, for example, damaged part needs to get remade. It's a fire drill in many factories when something needs to get remade because it was damaged and you have a ship date to meet versus it happening automatically. It's a simple trigger that triggers that part or several parts need to be reproduced. And it doesn't have to be difficult. It doesn't have to be chaos. It can be organized and done rather easily. The final one, which is the one that many people think of as the most logical tie-in with the smart factory and IIoT, the Industry 4.0, is the predictive maintenance. This is actually the piece that is growing very quickly now, where we tie in with these smart sensors and tracking machine hours, tying all the machines together in the world and following the log files of these machines to find out when something is going to break and alert the company before it breaks to allow them to make a decision in terms of fix it, continue running, bring in a technician, etc. But it allows you to make the decision before something breaks. Nobody likes downtime, but when you can plan for downtime, it's a lot better than having unplanned downtime. Well, thank you guys for attending. I hope it was beneficial for you. I will hand it back to Jörg.
Thank you very much, Jason. So this concludes now our webinar presentation. Again, in the name of Biesse and 2020, I really want to thank everyone for participating on this webinar today. You will also see on this slide here the contact information. Send your questions or comments or whatever area you're interested in, please, to these email addresses. Thank you so much for joining today. Have a great day. Talk to you soon. Goodbye.